Welcome back to Worms Maths Academy. Just had quite a few requests for this exam, so I thought it was time to fire up and have a crack at it. So I'm sure I've done this before, but probably 3 years ago when it came out. So pretty much exactly the same as all the other exams in this study design. We've got 4 questions, sometimes I have 5, and we've got 20 multiple choice. Don't forget to like, share, subscribe, turn on notifications, blah, 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 whatever people say. Share it with your friends just so that they can get a good idea of how to do the exams. There was one more thing I had to tell you, but I can't remember what it was. I've forgotten. Anyway, let's get down to it. This one here, we have the range of this function is. You can just graph it, or you can use max and min, depends on which calculator you've got. The main thing you've got to do is, because it's got a negative gradient, it's got to go downwards. So at -4, when you put -4 in, which is inclusive, we get 5 minus -4, which is 9. So we include 9. When we put 5 in, it's not included, and we get 0, and that's 0. So, because that's not included, our range is 0 to 9 inclusive, which is this here. Most people always assume because it's left, this point's going to be lower, or, yeah, you just got to make sure you graph it. Okay, this next one here, the period. Period is 2 pi, it's a cos graph. Don't forget if it's tan, it's just pi on 2, which is 4. So we can scrap all those. Our range, well, our center is at 1. Our amp is 2, so we add 2 and subtract 2. So our max is 3 and our min's -1, so it's B. Okay, part of the graph here is shown. F dash of x, the gradient is negative. When is the gradient negative here? Well, it's negative there. And it's there. Make sure they say, so this is the original graph and we're looking at the derivative graph. Sometimes I'll say this is the derivative graph, when is it negative? Then it gets confusing. So here we know it's from -infinity up until 2, not including, and from 1/3 to infinity. If it's strictly increasing, don't forget that that will include the turning points. But in this case here, we want C. The average rate of change of this function, the easiest thing to do is define it and then just use the gradient formula. So 3x squared minus 2, I think it was root x minus 1. Either case, you can just do the same thing. Just check it, make sure you haven't stuffed anything up. It's 3x squared minus 2 root x, it's plus 1. Okay, and then we want f of 3, because average rate of change is just your gradient between 2 points. F of 0 over 3 minus 0, 25 on 3. Nice and easy. Okay, which of the following is the inverse function of this? So we've got domain, so if we look at this, if I put 3 into that, we're going to get the square root of 0, which is inclusive. If I put a large number into that, I'm going to get 2 times a really big number, minus 6, which is still quite large. Square root, it's still large again, so it's going to be from 0 to infinity. So we can scrap. Next, find the inverse. X equals root 2y minus 6. X squared is 2y minus 6. X squared minus 6 on 2 equals y, x squared plus 6. Okay, which one's got that domain? Oh, we've only got one answer. Okay, consider the graph of that function. The square of the line, length of the line segment joining the points for that graph. Okay, so pi on 4, 3 pi on 4. Let's define it again. Now it says the square, so we don't have to square root it to find the distance. Sine 2x it was. Make sure your calculator's in radians. Sine 2x. Define. was 3 pi on 4. So we want f of 3 pi on 4 minus f of pi on 4 squared plus 3 pi on 4 minus pi on 4 squared. Simplify. What? Oh, I didn't put pi, I put that. Pi squared. Okay. So of course you can go transformation, fraction, combine. Pi squared plus 16 on 4. Number of pets owned by each student in large schools of probability distribution. If two students select probably they own the same number of pets, so they either have 0 together, which is a half times a half, which is 0.25, or they have 1 together, which is 0.25, 25, so 625. Of course, I need 4 numbers after the decimal point. 0.2 times 0.2 is 0.04, and 0.05 times 0.05 is 5 5s 25. We need 4 numbers after the decimal. Okay. So that and that gives us 0.29. That is going to give us 0.0650. 0.355, or you could do it on your CAS, obviously. Switching backwards and forwards is a bit of a pain in the ass. Okay, let's have a look. So it looks like we've got a cos graph. They're all cos. Our center is at 5. It's an upside down cos graph, unless it's sine, but we'll assume it's cos because most of them are cos. So if there's the center at 5, it's got to go up 5 and down 5, but it's negative, so negative 5 cos. My period, 2 pi on n is equal to 14. Switch these two. Pi on 7 is equal to n. So pi on 7 t. Now is that graph there? Center, up and down the amplitude, and it's an upside down. Yep, that's it. Okay, given that d dx of x e to the kx is that, then okay. So I'm going to change this. If we say y equals x e to the kx, dy dx is equal to this, but I'm going to expand it. Kx e to the kx plus e to the kx. Now basically what we want to integrate is this bit here. So if we bring this to the other side, we get dy dx minus e to the kx equals, because we've got a k there, I'm going to put the 1 on the k out the front, and that equals x e to the kx. From here, if I integrate this side, I've got to integrate this side. So if we integrate dy dx, we're going to get 1 on k times y, but we know what y is. Y is x e to the kx minus 1 on k, the integral of e to the kx dx. Because we've integrated that, we can put a plus c, and that equals that integral x e to the kx dx. So let's have a look. That, they're the same, and then our plus c. So our answer is D. So it's not something you can do on your you can't really do it on your calculator. You sort of got to do it by recognition and by hand. So that's D. Okay, for the curve, x squared minus 5, the tangent of the curve will be parallel to the line connecting the positive x and the y-intercept. Okay, if we let x equal 0, we get y is negative 5. If we let y equal 0, we get x is plus or minus root 5, but we only want the plus one because it says the positive. So we've got the point root 5 0, and 0, negative 5. So the gradient, y2 minus y1, that's 5. x2 minus x1, root 5, which is 5 root 5 on 5, which is root 5. So you want to know when this gradient, the tangent of this, is equal to this gradient. So dy dx is 2x, and that equals root 5. So x equals root 5 on 2. So I worked out what the gradient was of those two, between those 2 points. I found the gradient for that, and I set them equal, and then solve for the x value, because it says when x is equal to. Okay, the function has property that. Okay, so with both calculators, the easiest thing to do, x squared, define as f of x. Now on this calculator, on the other one you don't need to use judge. On this calculator you need to use judge. And then we put in whatever the function is. F of x minus f of y. If I can get f of x minus f of y equals x, well, y minus x, f of xy. Y minus x times f of xy. Okay, then we hit enter. It says undefined. Next one, x squared plus x to the 4. Still undefined. Just hit enter. X log ex. X times natural log of x. Still undefined. 1 on x. True. So it's got to be this one. And if you were to test it, like f of x is 1 on x minus 1 on y is equal to y minus x times 1 on xy. That would be because if we got this over a common denominator of xy, on top that would become y, on top that would become x, which is y minus x, that, times 1 on xy, which is y minus x times f of xy. The graph of the function f is obtained from the graph of the function g with rule that by a reflection in the x-axis. So if we reflect that in the x-axis, we get negative root 2x minus 5, followed by a dilation from the y-axis factor half. So that's f of 2x. When it's from the y-axis, it's the reciprocal. So that means wherever we've got an x, we replace it with a 2x. So we get negative 2x minus 5, negative root 4x minus 5, which is D. Consider the graphs below. The area of the shaded region could be represented by... Okay, we can't just do the top graph minus the bottom graph because they've got different terminals. So if we did the top graph, f of x, between 0 and D, minus the bottom graph, g of x, between A and C, that would give us the right answer. It can't be that, can't be that. 0 to B, can't be that, because it's not getting this area here. 0 to A, f of x, that could be that. A to C, A to C, that would be right. But then D to B, B to D would give us that area again. That's wrong. Oh, that's exactly what I said before. They're the same. Okay, a rectangle is formed by using a part of the coordinate axis on the point UV where U is greater than 0 for 4 minus x squared. So don't think of that as UV, think of it as U 4 minus u squared. So our area is going to be u times 4 minus u squared. U 4 minus u squared, which is 4u minus u cubed, maximum area of the triangle. So 4x minus x cubed. What are the values it was between? 0 and 2. Interactive calculation, max, fmax, 0, 2. 16 root 3 on 9 is our maximum. You could derive it, set it equal to 0 and all that sort of stuff, but much faster on a CAS. Okay, a box contains 6 red marbles, 4 blue marbles. The 2 marbles are drawn without replacement, so you don't put it back in. Probably are the same color, so we could get red, red, or we could get blue, blue. Red is 6 on 10 times 5 on 9, because we don't put it back in. Blue, 4 on 10 times 3 on 9. Okay, can we cancel? 2 and 3. 1, 2, they cancel. 1 on 3 plus 3 on the bottom. 5, 2. 2 on 15, make that 5, 5. 10 on 15. What have I done wrong? Bloody hell. I could just do it on a calculator. 6 on 10, 3 on 5, 9, how many's left? 5 on 9. So they cancel. So the first one's 1/3. 4 on 10 times 3 on 9. So that's a third on the bottom. 5. 2. 2 on 15. I don't know how I did that before. So I get 7 on 15. Don't know what I was doing. Okay, random variable x has a mean of 12. So 12, 12.25, 12.5, 12.75, 0, 1, 2, 3. Okay, the random variable z has a normal distribution. Probably x is greater than 12.5. So here, that's a z value of 2. So z is greater than 2. If we had to go on the other way, that would also be the same as z is less than -2, but that's not there because it's 2 standard deviations to the left. That area and that area are the same by symmetry. Okay, inside a container there are 1 million colored building blocks. Okay, because there's a million and we're going to get a sample, we know that this is binomial. There's known that 20% of red blocks are red. A sample of 16 blocks is taken. For samples of 16 blocks, so n is 16, 20% of them are red. P hat is a random variable, the number of the distribution of sample proportions of red blocks. So if P hat is greater than 3 on 16, we know that P hat is x on n, so x equals n times P hat, which is x times 16 times P hat. It's going to be 3. So that's the probability that x is greater than or equal to 3. The probability that P hat is greater than or equal to 3 on 16 is equal to the probability that x is greater than or equal to 3. And it's binomial 16.2. Interactive distribution discrete binomial CDF 3, 16, 16, 0.2, 0.6482, come back, A. The continuous random variable that has a probability density function, that find the value of A such that the probability that x is less than A. So we've got to go from 3 pi to A, f of x dx, and it equals root 3 plus 2 on 4. Of course, we're going to do our CAS a quarter cos x on 2. So we're going from 3 pi to, let's say z, a quarter cos x on 2 dx and that was equal to, I think it was root 3 plus 2 on 2, 4, I don't know, on 4. Now, interactive advanced solve. Nah. We're trying to solve for z, and we know that z has to be between 3 pi, and that's less than or equal to z, which is less than or equal to 5 pi. What? Given. Bloody hell. 14 pi on 3. Because you know that that value, a, has to occur somewhere within this domain, so you can restrict it. So that a discrete probability distribution with a random variable x shown in the table below, the smallest and largest possible values of e of x are. So e of x, multiply them, negative a, 0b, plus b squared, plus 4b squared, plus 0.2, that's e of x. Okay, so we get negative a plus 5b squared plus 0.2. We also know a plus 4b plus 0.2 equals 1. So a plus 4b is equal to 0.8. So if a is 0, b would equal 0.2. If b is 0, a would equal 0.8. So if a is 0 and b equals 0.2, 5 times 0.04, I'll stuff something up there. That's 0.8. So 5 times 0.04 plus 0.8. This is if a equals 0 and b equals 0.2. 0.2 plus 0.8 is 1. If b equals 0 and a equals 0.8, if b equals 0, that's going to scrap, and a equals 0.8, we get negative 0.8 plus 0.8, which is 0. So e of x would be 0 if a is 0.8, and e of x is, and b is 0. E of x equals 1 when a equals 0 and b equals 0.2. So the smallest and largest, 0 and 1. Okay, consider the transformations as defined. So 0 to 3, f of x dx is 5. I want to find negative 3 to 0, g of x. That's a reflection in the y-axis. So if I reflect that in the y-axis, just say negative 3 to 0. If you reflect it in the y-axis, that becomes 0 to 3. So first thing, 0 to 3, g of x dx. That would equal 5, because they're the same. It's a dilated 3. So that's 3 times 0 to 3, g of x dx, which is 3 times 5, which is 15. Then if I translated up 5, I'd have 15 plus 0 to 3, 5 dx, because that would be the same as so 3 g of x dx, and then plus 5 dx, which you know you can separate. That we know is 15. This we know is 5x between 0 and 3, which is 15 minus 0. 15 plus 15 is 30. So you've got to make sure you know your reflections, dilations, translations, and all that sort of stuff, because it makes it so much easier. Okay, that's multiple choice down. Next off, we'll have a crack at part 2.